Hey guys, good morning and welcome to the new session of MuleSoft online learning. So within today's session, we will be discussing about one of the latest hot buzz around Kafka streaming. So nowadays there is a lot of discussion going on about the streaming platform, and Kafka is one of the leading player in the same sector. So today's video will be in two parts. The first part we will be discussing around the different concepts of Kafka, how the Kafka what are the different constituents of Kafka streaming, and what are the use cases. And after that, we will see how we can realize the Kafka capabilities using a endpoint studio created using a Mule 4 runtime application. So let's get started. I will go directly onto the main Apache Kafka page and we will start with introduction sort of thing. So this is more on a conceptual level, and after that we will be moving towards the practical. So what is Kafka is all about? Kafka is a distributed streaming platform, and it is having multiple capabilities like publish and subscribe. It can store the stream of records in a ft durable way. So when we say durable, like even if one of the node goes down, the other node will be up, and at any point of time the data will remain available and process the streams of record as they occur. So it is near real time. So Kafka is basically used in two different classes of application. As I mentioned, because of streaming option available, it is used for the real-time streaming of data. Either it can be in the pipeline, so that reliably get data between the different set of applications, basically like within the share market or real-time Bitcoin valuations. These sort of platform on which very high speed of data and the timely data is more important. And similarly, the second one, application that transform or react to the stream of data. As soon as the data comes up, it should process or it should transform the data accordingly. So these are the two broad classes of applications. So let's go deep dive into the different aspects of Kafka. So there are few concepts around it, like it can span around multiple data centers, and Kafka clusters store the streams of record in the categories which are called topics. These topics are quite similar like we have in the other messaging platforms, like in um, EMS, the Enterprise Messaging Service, JMS, even RabbitMQ. So similar to that stuff, and each record consists of a key value along with a timestamp. Timestamp is also one of the crucial thing. Depending on that, Kafka decide whether to hold a particular message or to discard it. We will discuss about it gradually. So Kafka platform comes up with five different core APIs, that is producer, consumer, streaming API, connector API, and admin API. So as the name suggests, and the producer API allows an application to publish a stream of records to one or more topics, basically the publication part of it. Consumer API is to subscribe one or more topics and process them in the form of stream of record as it is being received. The third one, the streaming API, it is also being used as a stream processor. It basically consumes an input stream from one or more topics and produces an output stream to one or more output topics. So it's a pipeline sort of thing. The connector API, it allows creating some reusable producer and consumer that can connect to a particular Kafka topic, and they can connect to different data centers as well or data systems. So like if you want to create or to set up a linkage between a RDBMS, this can be used connector API. Apart from that, there are some housekeeping works related to admin, like managing the topics, deleting the topics, looking for the brokers. So these are being handled by the admin API. Now going to the topic and logs. So what is topic? Topic is like a category or feed name to which all the particular incoming messages are being published. So these are like multi-subscriber. If a particular message is being consumed by a subscriber, it doesn't change the status for rest of the subscribers. So in short, a topic can have one or many consumers to it that can subscribe to that particular data written onto that topic. So for each topic, Kafka cluster maintains a partition log like this. It is being mentioned, and uh, as we move from old to new, it writes onto the new partitions every time, and depending on the time of retention, it starts moving away, or you can say it starts deleting the previous sort of data depending upon the retention period which we need to set. So coming to that particular point, each partition is ordered in immutable sequence of records. In a structured commit log, the record in the partition are each assigned a sequential ID number that is like 0, 1, 1, 2, like this. And these are called offset, which uniquely identify each record within a particular partition. So it's like a different streams are going on, and the message is being distributed along the different partitions. The cluster, it persists all the published records whether or not they are being consumed or not. Usually a configurable retention period, so that was I was talking about earlier. So if it is being set to 2 days, after 2 days of record published, it will be discarded to free up the space. So it will remain available for the 2 days, and after that it will be discarded so that new message can come up and take up its place. Apart from that, this offset is controlled by consumers. So a consumer can put up the offset linearly as it reads out the record. So once the record is being already read, then it can be the offset can be changed so that it is available for the next set of incoming record. So that's what like this saying, a consumer can reset an older offset to process data from the past, or skip ahead to the next or most recent record and start consuming from now. It means the real time as it comes. The combination of this is like very cheap if we compare to the other enterprise level messaging systems. So that's why we can use Kafka as more reliable and uh, less cost uh, bearing tool, and it provides a different command line tools to uh, create the topic, and it is very easy to set up. We will discuss about it in the later part of this video. So there are multiple other factors or features which makes Kafka quite unique. These are like distribution, geo-replication using the mirror maker, the producer, consumer, the consumer settings are being there, and as I mentioned, Kafka cluster maintains multiple server instances, so the message can be held onto the different partition levels, and it can be consumed by, or it can be subscribed by different set of consumer groups, and the status of messages inside the partition for each consumer in a consumer group remains independent of the others. So um, uh, it's like a logical subscriber group, I must say, and each group can composed of many number of consumer instances, and it can be scaled in and out. So that's the beauty of Kafka platform. Apart from that, it is multi-tenant in nature, and it guarantees a high level of message delivery. So basically, how it achieves that, it provides a replication factor. So we can tolerate up to n minus 1 server failures. Still, we have one more um, copy of a particular topic to store all the incoming records. So in most of the cases, it will be up and running, and you can retrieve any data at any point of time, even if there is a case of failure. So messages sent by a producer to a particular topic partition will be appended in the order as they are sent. Um, Record M1 by a producer as a record M2, then M1 is sent first and M1 is a lower offset than M2 and appear earlier in the log. So basically it follows FIFO, first in first out, and the consumer instances sees records in the order in which they are stored in the log. And in most of the scenarios, Kafka is being used as a messaging system or as a streaming. So it is like queuing and publish and subscribe format. So in a queue, it is like a pool of consumers which can read from the server, and each record goes to one of them, and PubSub is like a broadcast, and there can be multiple subscriber to the same. And there's a different use cases around the queuing and the publishing, publish subscribe the PubSub. The When you are using queuing, it allows the processing of data over multiple consumer instances, and you can scale up your processing. However, queues, as the name suggests, it is like one to one. It's not multi-subscriber. So one process can read the data and it's gone. Whereas if it is being PubSub, then it allows you to broadcast the data to multiple processes, and the only concern over here is it has no way of scaling up the processing. Every message goes to every single subscriber connected to it. So there is a concept of consumer group within the Kafka, which generalizes these two particular concepts. With a queue, the consumer group allows you to divide up the processing over a collection of processes. That is also known as the member of a particular consumer group. With PubSub, it allows the broadcast message to the multiple consumer groups basically. So the same message will be available to the different sets of subscribers which are having the same configuration of consumer group. Okay, so Kafka can also be used as a storage system, and it will perform the same ways, the performance wise, whether you are having 50 KB of data or it says the 50 TB of persistent data on the server. Um, the performance level will remain exactly the same. So it can also be used as a storage system, and in most of the cases it is being used as stream processing. Like it can uh, it is it is used for enabling the real-time processing of the streams using the streams API as we discussed earlier, and like it can be used for the transformation purpose as well. Like as soon as a stream of records is being received on a particular queue or topic, it can be used for further high level of complex transformations. Okay, so handling of out of order data, reprocessing input as the code changes, performing stateful computations, etc. So this is like some of the use cases for stream processing. So this was the official page of Kafka, and there is a way to get it installed on your local machine. So during the rest of the part of this video, we will be discussing about what are the steps to set it up. So let's quickly go over there. There is a download button on the left hand side of this particular page. If you click over there, it gives the option to download the latest version, that is the stable 250. So you just need to go with the source download, Kafka 250 src, and after that you can You have to make some process specific like steps which you need to take care, and it will set up on your machine. So what are those exact steps? Let me walk you through. So this is the download page of the same 250 Kafka version. uh, there are certain you need to extract this particular zip file onto your maybe C drive if you are using the Windows machine, and if you are using the Mac machine, so in that case you can put it in your users folder, users directory. So let me show you. I have uh, downloaded it from here and taken out the contents of this particular folder, and I'm maintaining it somewhere here under Kafka 250 SRC. So there is a particular folder structure which it follows. It is having a bin folder that is having all the shell scripts. The relevant one for us will be the zookeeper server start sh and the Kafka server start sh. In turn, these two shell files look for some configuration files, so which comes under this config folder, the server properties and the zookeeper properties. I will walk you through the specifics of that, but let's first understand the structure of this particular Kafka SRC folder. So apart from that, one of the thing is Gradle. So just in case if during the processing it shows anything related to like you need to install Gradle to move forward, so you can get it installed on your respective machines. I can share one of the link for that. So this is the Gradle installation. It gives a very easy to follow instruction based. So if you are in Mac OS, you can use the homebrew option. It will directly install, or if you want to install using a manual method, there is a particular way to download the binaries, and you have to create some of the folders like within the C within the Windows. You need to create a C Gradle, and then you have to extract all the contents of it and need to set some of the environment variables, variables, and within the path you have to give the bin location of Gradle. So once it is being done, irrespective whether you are on Mac or on you are on Windows machine, you can simply type Gradle hyphen v. V stands for version to and just hit and enter. It will give the version of the Gradle. So just in my case, let me show you if it is there. So even I am using the same Gradle version, the latest one, 6.3. It comes up like the other relevant information of open source, like what is the Kotlin version, Groovy version, Ant version, and what are the JVMs being used, and what is the current OS configuration. So it means Gradle is already installed on my system, but now you know what is the process to get an install on any of the operating system. I will copy paste all these links in the description part of this video, so stay tuned. So now let me go back to the this particular path. We were discussing about the configuration part. So there are some changes which we need to do. We will first change the server properties. So you can maybe right click and open with any other file, or in my case I will be drag dropping over the ultra edit. So it is already open, that's why. So you have to directly jump onto the line number 30. Earlier it will be like in the commented section, earlier it was like this. Now you have to remove this hash so as to uncomment it, and there will be something like there will be some different string over here, and you have to replace it with your local host, because we are executing this POC on a particular your local laptop or your desktop. So we need to replace it with localhost. And apart from that, you will also like to see what are the settings we can observe within the zookeeper. So there are certain things like the client port 2181 is being used for the zookeeper, and what are the maximum client connections for the non-prod config. Zero means it doesn't have any limit on it. And on the server property side, there are certain other fields as well which you would like to uh, pay attention, like uh, these values like send buffer and receive buffer. These are in bytes. Apart from that, there are certain tmp files for logging all the Kafka related logs. So this is pretty much of it. Yes. So let's get started with the bringing up our Kafka server. So we will be following this particular manual, you can say. We need to execute some of the things, like we have to first start our zookeeper, which will be setting up all the initial groundwork for our Kafka server to get start. So let's copy paste this and go over here. I will copy the location from here. One moment, guys. So you can open any terminal or command prompt on your side and go to this particular location in which you have already extracted the Kafka zip, and traverse up to the src folder, and don't go inside bin folder, because these commands are written on the level of bin folder. And you can just copy paste and hit enter. By the time it starts all the things on the zookeeper level, let's open up one more window for it. I will copy paste the same location, go over terminal window, cd, and this time I am going to run the Kafka server. Hit enter. So now it is showing the started the Kafka server. Here you can see, and similarly it is started, zookeeper started writing all the log related things in some of the files. Now we will create one of the sample topic. So we will be running kafka topic.shell script, and it will be going to create within the bootstrap server. The bootstrap server, I will tell you, like bootstrap server is the same as the Kafka server, which is listening on 9092 port, and we are putting a replication factor of 1 because we are working on a local setup, and we don't expect any downtime or so that's why I'm putting the replication factor as 1 and partition as 1. And I will change the topic name to maybe test topic, and I will copy paste this particular line onto the command prompt and hit enter. So you can see created topic, test topic. Let's go onto the back, onto the server level. Let's see if there is something. You can see, so created log for um, test topic, test topic partition checkpointed. So it seems on the Kafka server, it has logged some of the details about the test topic which we have created, along with the offset and all the things like partitions and all the things. Yeah, you can refer all these particular values which are specific to the test topic. Now, test topic is created, but how to be sure like it is properly created? So there is a particular command to check that. So within the bin Kafka topic as such, it will list all the topics available on the localhost 9092 bootstrap server. Hit enter. So it shows this is the test topic which is being maintained. So every time your mule server Kafka server gets rebooted, it gets refreshed, all the topics vanish until or unless you are maintaining it or persisting it somewhere, either on the DB level connectivity or on the file level connectivity. And since on my local machine I have restarted my system couple of times, so that's why the previous topics are not visible. It is showing only the current one. Okay, so after that we are going to send some dummy message on this particular topic. So our topic name is test topic. I will hit enter. So now it is giving me option to put some messages over here. So I will put hello Kafka, are you started finally? Now again we will set up our consumer. We will open a new command prompt, and we will go to the same parent folder of Kafka src, and there is a particular command to consume those messages which we have just published. So basically it will look for bootstrap server 9092 port, and it will check on a particular topic. In our case it is test topic, and from beginning whatever message are being put in, we are going to check. So these are the two messages which we have published from the Kafka producer side, and finally it is getting consumed at the consumer level. So let me try to put one more message. We officially welcome you on board. So as soon as you type this message and hit enter, it comes onto the consumer part. So in this way I have shown you how the messages are being propagated from Kafka producer to the Kafka consumer. We will be using similar approach for setting up one of the sample Mule4 app using the Anypoint Studio, and for now I will terminate the consumer session, because I don't want the message which are will be published from Mule side to be consumed by this particular window, this particular instance. So I will terminate it forcefully. So this is the first part of our Kafka introduction. In this particular video, we have understood like the basic concept behind the Kafka and how to set it up on local. In the later part of the video, we will be discussing like how to connect to Kafka platform using a sample mule application and how to debug the code as well. So thanks guys, thanks for joining me in this wonderful session. So stay tuned for the next upcoming session on the same. Thanks a lot.